Hello, Pathways class. Going to talk about a little bit more about the Richter scale today and the modified Mercalli scale, and because I want to make sure you understand how these work. So the Richter scale we know measures the intensity of earthquakes. As you go through the Richter scale, every time you go down a level, you're multiplying the magnitude of the earthquake by 10. So it would be a 1 going from a 1 to a 2. You're not just going up one step, you're going up. It is 10 times more powerful than this one. So if I was feeling an earthquake that was a level 1, and then I felt a level 2 on the Richter scale would be 10 times more powerful than the one I just felt. So I felt a 2, wasn't too bad, a little shaking, all right, possibly, most likely. But then if I felt something that was a magnitude 3, well, then that would be 10 times that one, which was 10 times that one. So 100 times stronger than that. So every time you go up a level, the magnitude goes up by 10 times that amount. And you'll also often see these in decimals. So it'd be kind of like if I had $10 or if I had 100, I have 10 times the amount of money. That's quite a bit. But I could have in between. So you could have a 1.1 or a 1.2 or a 1.3, just like you could have, $20 or $30 or $40. So a 1.5 on the Richter scale would be not quite 10 times as much. It'd be about half of that. So it'd be like having $50. Still a big jump. 1.5 is still a big jump, just like it's a big jump from $10 to $50. So every time you go up, you're going to move up a whole level. You move up 10 times that amount. So like a 2.5 would be, if 2 to 2 to a 3 would be like going from 100 to 1,000. That's a big jump. Going a 2.5, well, 2.5 is still a big jump. So if you're going from 100 to 1,000, if you're going about halfway, that's still a pretty big jump in magnitude, right? How much is there? If you want to get a better idea of the energy, and let's see if I can pull this up here. Right. So relative energy. I'm going to make this picture a little bit bigger here, hopefully. Maybe I am. Whoa, I'm moving it around. See if I can zoom in on it. There we go. So here's relative strength or energy. Like how much energy is in the earthquake. If it was a 1, it would be like having $1. If it was a level 2, that's 32 times, about 32 times the energy as a level 1, a Richter scale 1, magnitude 1. So the energy level goes up. You go up magnitude 10 times per level. The energy goes up about 33 times for every level you go up. The amount of energy. It would like being a clap, and then a clap, and then a clap. That energy level goes up 33 times every time you move up on the Richter scale. So as you can see, if you're the difference between a 1 and a 3 in energy-wise, it would be the difference between having $1 or $1,024. That's a lot more energy in that earthquake from just a 1 or a 3. This is still all doesn't give people like, all right, well, what does that mean to me? So the USGS still uses this modified Mercalli scale, okay, to give you some description of what it might be like. A 1, detected only by a sensitive instruments. You probably wouldn't even feel that. 2, felt by a few persons at rest, which means if you're just sitting there, you might feel it, especially on the upper floors. Delicately suspended objects may swing. So you have something hanging, it may swing a little bit. If it was a 3 in Roman numerals on the Mercalli, this would be a 2.5. Felt noticeably indoors, but not always recognizable as an earthquake. You just might think, oh, maybe the building got hit by a car or something like that, and it kind of shook the building for a second. So go ahead and read these. Pause the video if you have to, and read these modified Mercalli and look over here at the Richter scale. All right. So look, here's a Richter scale. Remember, every time you go up, it's 10 times the magnitude. Every time you go up a scale, it's 33 times the amount of energy. But look at what it is here. Now, this also could change based on where it's at. So let's take a quick model here. If here's the surface of the Earth, okay, and the hypocenter or focus, if it happens 4 miles down, if you're having an earthquake 4 miles down, and it's a 4 on the Richter scale, you still may not really feel that up here because it's 4 miles up. All right? But if it's 4 miles down at the hypocenter, but this ground here is kind of hard, that energy still may travel up. If it's 4 miles down and a Richter scale magnitude of 4, and the ground is really soft and it can jiggle a lot down here, you may not feel it at all. All right? If you have here's the surface, here's our crust, and this is only 1 mile down, 1 mile, and you have a 2.2, you might actually feel that quite a bit because it's only a mile down. All right? Let's look quickly at the USGS today, where they're at. USGS earthquakes, real time. All right. Now, these are interesting. For a long time, these are in Oklahoma. Couldn't figure out why these were happening. They realized it's because of fracking, cracking of the earth to get natural gas out. All right. Let's look at one here. All right. So here is a magnitude 2.6. And this happened in British Columbia. Let's click on that. All right. It was along a fault. Do we have a did you feel it here? Origin. Depth, 11.3 kilometers. So that's pretty deep. A 5K run is 3 miles. So a 10K run would be 6 miles. So this is 6 miles deep. And a 2.6, I don't even think they would have felt that. Do they have it on here? Let's see. I don't think they have a Mercalli on there. Probably couldn't even feel that. Impact summary. Nothing. All right, let's go back and pick another earthquake. These are all pretty deep. 10 kilometers, 6 miles down. Here's this one. At Oklahoma, 33 kilometers down. You would have never felt that. Now, here's an interesting one. A 5.2. That's halfway up the Richter scale, but it's 49 kilometers down. Off the coast of Nicaragua. Okay. So that probably was not magnitude greater than 2.0. And that one wasn't even felt because it was so deep. All right. I have found some raw footage, and this is a pretty good video, but there's other ones. This was a 9.0 earthquake, 9.0 on the Richter scale. And if I remember correctly, this is the highest modern earthquake ever recorded, a 9.0 off the coast of Japan, 2011. So it was an earthquake and it caused a tsunami. So I'm going to go ahead and link this into our Google Classroom. I'm also going to link in a form, get some feedback from you about how this whole process is going. Is this working for you? Is this not? Any feedback you can give me. So take a look at this, some raw footage of some of the Japan 9.0 magnitude earthquake, and look for some other ones. There's lots of I don't want to say great videos, but interesting ones scientifically of this. All right, Pathways. Hopefully you're all doing well. It's going to be a beautiful day out. Maybe you can get outside a little bit today and get some sunshine. But so look for this link of the YouTube video and the form, and please fill that out. Okay, bye.